Hello, students. The topic for today's presentation is aperture, exposure, and depth of field in photography. So, what we discussed in the last class, so we learned the technology and the role of technology in learning photography and the characteristics of the camera lens, and a brief introduction has been given. And now we'll move to learn the some other few techniques which are basic required for a photography. So now we'll see what is aperture, exposure, and depth of field. Hope you remember the bucket, water, and tap illustration which I shown in the last presentation to explain the aperture, exposure, and the light sensitive medium, how it records, how a camera records a photograph taken by the camera. So now we will see these technical details about these areas, these elements in photography. So the eye, first we will see the camera as our eye, we will relate it to this an eye. The three things: iris, lens, and light sensitive area, these are all related to the digital camera. So as you can see from the picture, iris is the exposure, the changes the amount of light entering the eye. You see, as you can see, this iris of a human eye changes the amount of light entering the human eye. And B can be termed in a camera as lens, which can change the shape to focus. How to focus? To change the shape to focus. Hope you remember the focal length, the image plane, and the focal point plane, axis plane, where the image and the lens can meet to get a clear picture, that is focus picture, what we call it as the focus plane. So here the lens is the lens part, it's B, can change the shape to the focus. And C is the light sensitive area where an image is formed. Okay, the same way we'll see the camera. The cameras are very similar to our eyes. See the lenses, aperture, and the film. Iris, lens which focuses, aperture, that is the iris which allows, changes the amount of light entering the eye, and lenses, instead of changing the shape, here they move closer or further away to the light sensor to get a clear picture, what we call it as the focused picture. Light sensitive area, which is in the human eye as the behind the eyeballs, here it is a film or digital sensor, it's a light sensitive area. Aperture is the lens controls the amount of light reaching the light sensor. So a shutter, you can include the fourth element, which is a shutter, which also opens and closes to let the right amount of light fall on the light sensor to and get a correctly exposed image. So this is the basic mechanism of a digital camera, where we are relating to the human eyes. Okay, I hope now you are clear with the light sensitive area, lenses which helps to make a clear or focus picture, aperture which controls the amount of light reaching the light sensor, and the film which is the light sensitive area where the picture or image gets recorded. So here the additional element is the shutter, which is a mechanical element which opens and closes to let the right amount of light fall on the light sensor and get a correctly exposed image. So when it comes to photography, so these things are the basic controls which is in our hand to take a correctly exposed image, to take a perfectly exposed picture. Okay, so these are all our controls. These are all in these things are all in our hand, our control. Only learning things with different combination will help you to make a perfect picture. If you see a digital camera, it looks like the cross-sectional view of a digital camera. You can see the lens part, lens assembly, that it goes moves away and further from the light sensitive medium to capture the picture, and the aperture part which allows the light to fall into the light sensitive medium, and at the end it's the light sensitive medium which captures the pictures. Now coming to the types of lenses, when it comes the lens movements, removable lenses for SLR cameras. I hope you remember SLR, single lens reflex cameras, and fixed on these type of compact cameras. In the above picture we can see the compact cameras, box cameras or point and shoot cameras. These lenses are fixed. For SLR cameras, these lenses can be removed and reconfigured. The, so, in that, one thing we have to know about lens, which is they name it as prime lens, which is the fixed focal length. As I said, no, there is you can't adjust the lens assembly towards and away from the light sensitive material to get the focus picture. So it's a fixed focal length where you can take a picture. So zoom, which is the most common used lens, which has a range of focal lengths. Okay, the focal length is the which helps you to get a focused picture in the object plane in front of the camera lens. So there are two types of lens, which is a prime lens which has a fixed focal length, and zoom, which is the most commonly used lens which has a range of focal length. What does the focal length mean? If you see from the camera, so these are all the focal length, 600 millimeter to 15 millimeter. What we call it as the wide angle. So wide angle is equal to large field of view. Just wide angle gives you large field of view. So the focal length will be under 50 millimeter. So you see from 28 millimeter you can get a wide view, large field of view. If you equate with the standard lens, which is 50 mm, same perspective as the human eye. 50 millimeter, how the human eye sees a object or sees the visual, which is the standard lens. The other category is the telephoto lens, which has high magnification focal length over 50 millimeter. So there are three categories of lenses: wide angle lens, which is below 50 millimeter; standard lens, which is same perspective as the human eye, which gives in the focal length of 50 millimeter; and the telephoto lens, which is have which has the high magnification over 50 millimeter. So okay, the focal length helps you to capture the perspective, also the perspective of a image, not only the focus. To get a focused picture, the focal length plays a major role in changing the perspective as how the eyes capture the image. Okay, widely covering, which is C, which can cover 15 millimeter, which can cover 110 degree of view. See, 110-degree view of an image from the camera lens. The 28 millimeter 75-degree view, and the telephoto lens of 600 millimeter, it covers a 200 millimeter covers the 12 degree. So it focus will be the perspective will be only towards the 12 degree of towards the visual it can capture, and the 4 degree for 600 millimeter. It is a view, for example, it's a field of view, or we can say the perspective view, which is called the focal length. Generally it is categorized as wide angle, standard, and telephoto. Large field of view, which is 50 millimeter, and standard lens 50 millimeter, and over 50 millimeter is the telephoto lens. Then moving to aperture. As I said, the aperture is the element which controls the amount of light falling into the camera exactly to to the light sensitive medium. We can use the aperture to change the amount of light entering the camera. So here the aperture is mentioned using f-stops. To describe aperture, we use f-stops, and these have an f number. If you see the lens part, no, f2, f2.8, f4, 5.6, 2, 2.84, 5.68, 11, 16, and 22. So these are all the numbers, f-stops, to change the amount of light entering the camera. How this can be classified as lens, wide angle, standard, and telephoto, aperture, small apertures and large apertures. For example, f11, f16, f22 are small apertures, only let a small amount of light through. So it's quite opposite. If the numbers are more, then it's a small aperture. So if the numbers are less, then the hole is big. For example, the large approaches f4, 5.68 through a lot of light. See, this is the 16. See the difference between the 16 and 8. In 16, the hole is small and compared to the f8. Okay, so for a sunny day you might need to use a smaller aperture to get the correct exposure. So if it is a sunny day, you don't need to open up the aperture ring or aperture to a larger extent. So it's the small is enough to capture the image. So a small aperture is enough to get the correct exposure during a sunny day. So small aperture, large apertures, what we have to keep in mind here is, larger the numbers, smaller the amount of light falls. Okay, no, okay, so large apertures let through a lot of light. See, numbers plays a major role. So this is the tricky thing where you have to keep it in mind. A larger f11, 16, 22, small amount of light. f4, 5.6 and 8, so a lot of light. So the previous lens what we have seen is, it is having up to a value f stop of 2. The 2 means it provides more light into the camera. 22, here the 22 will only allow a less number of light amount of light into the camera. So that is the concept of aperture in the SLR cameras. So each change of f-stop, either half or double amount of light entering the camera, the largest f-stop on a lens is called the maximum aperture. So if you see this camera lens, which is the maximum aperture is 22, the largest f-stop on a lens is called the maximum aperture. So the maximum lens aperture is important because it indicates the largest amount of light that the lens will transmit. A small aperture is equal to larger aperture, a brighter lens is equal to generally more expensive. See, what we can note down here is, a smaller f number, that if it in the lens the smaller f number is 2, is a brighter lens is generally more expensive. It has the capacity to allow more light. Okay, so that is the concept of aperture, the amount of light, how much should it fall into the light sensitive medium. The next one more concept is the depth of field. Changing the aperture of a camera also changes the amount of image that is in focus. So these three things, what we call it as the golden triangle of a DSLR camera: aperture, exposure. Okay, so changing the aperture of a camera also changes the amount of the image that is in focus. This amount is called the depth of field. See, so a particular lens with a particular aperture and focal length, no, it will be in focus. A particular area will be in focus, where before and away that particular area will be in out of focus. So the area which is in focus is called the depth of field. Okay, only light, there is a one more term, the cycle of confusion. Only light at the focus depth is exactly in focus, as we see in the butterfly. See, only light at the focus depth is exactly in focus. The rest of the depth of field are having varying circles of confusion. So further from the focus depth, the bigger the circle and the more out of focus that point appears. See, for example, if you see the circles of confusion as illustrated, the zone of acceptable sharpness for this particular lens under particular aperture value f stop value is this area, zone of acceptable sharpness. So if this subject or object stands in this particular field, then it will be in focus. Circles look like points in this zone. Even before it looks like circles, which is a subject out of focus, and the subject out of focus away. So this area is known as the depth of field. So the depth of field can vary between shallow and deep. You see, as you can see, the middle lines are the middle zone is clear and sharp, above and below are out of focus. Large apertures gives shallow depths of field. That is, small f numbers gives you shallow depth of field. Small apertures give deep depths of field. So there is one more thing you have to understand here is, you have to keep it in mind. If you go with this large apertures, there's a small f numbers will give you shallow depth of field, because the amount of light falling into the light sensitive medium through the aperture ring is more, which gives the shallow depth of field. The small apertures, the large numbers, gives deep depth of field, because the amount of light falling into the light sensitive medium is less and it is very narrow and focused, narrow. So it's a deep depth of field. So see, apart from using aperture, the depth of field can also be changed by varying the focal length. You see, earlier how this focus can be done using depth of field, we have aperture. How to achieve this depth of field we discussed. Even with the focal length, using aperture, even with the focal length, which is varying magnification away and towards the camera lens and the light sensitive medium, the lens assembly moves, where we can achieve the clear picture, focused picture. See, the first picture is taken using the normal focal length lens. As I said, wide angle normal lens, telephoto lens. So normal focal length. Here in this sequence, the focus distance and aperture are fixed at 5m and f 5.6. So aperture is more. Here a 70 millimeter lens is used to widen depth of field, 70 millimeter, which gives you the shallow depth of field. The short telephoto lens switching to 135 millimeter lens, which is again we are moving further. Telephoto lens has visibly reduced the depth of field, causing significantly more blurring of the houses behind the statue, because here it is 70 millimeter lens is used, here 135 millimeter lens is used. Here say in the third picture 300 millimeter lens is used. I am going back to the previous illustration. 70 millimeter here in between, 135 millimeter is here and 300 millimeter is here. See, 70 millimeter roughly some 30-degree views, and it is something lies between the 18-degree and 200 millimeter is something 10-degree of view. So your view, that is the perspective, is narrowed down, and this magnification will also result in taking the clear focused picture. See, as you can see, to achieve the depth of field, the focal length can also be used. For example, f5.6 with the 70 millimeter lens, 135 millimeter, narrowing down lesser perspective, and 300 millimeter lens where the background gets blurred, more blurring of the houses behind the statue. See, this gives you the shallow depth of field, and this gives the deep depth of field. Switching a 300 millimeter lens reduce the depth of field to the point where the buildings are reduced to soft abstract shapes. Okay, so apart from using aperture, the one more thing, the focus will also help you to achieve the depth of field what you want. See, for example, foreground is in focus. In this sequence, the lens is fixed 105 millimeter. F is for 4.5, f stop is 4. The focus distance altered. Here focus is the nearest house, depth of field is minimized. It has a shallow depth of field. In the middle image, no, the lens focused on the middle house, the depth of field now extends about 5 times further than it did in how we did in example 1. You see here the background is in focus, deep field, depth of field again. So even with the focus we can achieve this depth of field. So aperture, focus and focal length. How here, how creatively are you going to use of depth of field matters, which where we can use this depth of field, which helps you to separate your subject from the background, give a feeling of space or distance to a scene, highlight the area of the image. You see in the below picture, it will give a feeling of a space or a distance to a scene which separates the subject from the background. So this depth of field helps you to achieve creatively to distinct the background and foreground. What we obviously call it as the subject. Your subject will be the foreground, and to distinct the subject and the background, separate your subject from the background. But this can be achieved, you see the creative use of depth of field in these images. Okay. And in many cameras, no, the third point is the physical exposure or the shutter speed. Shutter speed is the exposure. How much time should I allow the light to pass into the light sensitive medium? Okay, the mirror and the I think, I hope you remember in the first class, that is the shutter speed. When you click a camera, a shutter will open, and what is the duration of the shutter to keep it open to record the image that is in front of the lens. So physical shutter will open for a small length of time, then it closes. So this allows the film or digital sensor to receive light for an exposure. So in digital compact cameras and video cameras, the shutter may be electronic, which is in the electronic, which is where the sensor is only receptive to light for the shutter period. When it comes to the physical shutter cameras, it is in our control. You see, the mirror will get raised, the shutter will be open, and the shutter opening will also decide the effect of the picture. So the effect of varying shutter speed also gives you a constant aperture to the image. See, the images, the shutter speed, the shutter opens for 1.3 second, and in the next picture 2.5 second, 4 second, 8 second. So if the shutter opens for 15 second, so the amount of light falls, no, is more exposed to more bright, you'll get a brighter picture. So the images start underexposed with a short exposure, and correctly exposed, you see mid in the middle, that is 4 second, and become overexposed, just too bright at 15 second. Where you see out of this one 5 pictures, where you can see which is underexposed and overexposed and properly exposed, correctly exposed. So if the shutter opens for a long time, then you will get a overexposed picture, and if it is for a lesser time, you will get a dark, the short exposed picture. A fast shutter speed creating a short exposure of the film sensor is required to freeze motion. If it is opens and closes very short in a short period, it will capture the, what you say, freezing motion or freeze movement. So for certain running or the objects in motion, you have to capture certain objects which is in which are in motion. You can go for the fast shutter speed. For example, 1 by 1000 second, if you put, no, it is like a microseconds, it will just capture the objects which are in motion, which require to freeze motion. A slow shutter speed which creates a long exposure can blur motion for interesting effect, as you can see down in the below picture. For example, if you are in sports, a cycle race or any sort of race, if or any activity or motion involved sports, if you want to capture or freeze the motion, you can go with the fast shutter speed. If you want to have some sort of interesting effects, the slow shutter speed will give you the blur motion, where you can try this with your even some of the smartphones or mobile cameras also having this effect. You just go to the pro, that is the professional mode, and if you find any option like shutter speed, just decrease it and just take a video or give a movement or take a video of any moving object, then you can feel this blur motion effect. And if you increase the shutter speed and if you take any moving object, it will try to freeze it. So the mobile cameras will help you to capture to some extent. It won't like digital SLR cameras. So very long exposure may be required in low light. So again it is connected with the light, with the aperture. If there is low light, you can open the shutter for a long time. So very long exposure may require this low light, but this can produce nice effects with these things. Okay, and there are some values which, if you change the shutter speed, which is equivalent to the other values with the shutter speed and the f-stop. So changing the shutter speed by one increment changes the exposure value by one stop, 1 by 30 second, 1 by 60 second, 1 by 90, like that. Changing the aperture by one increment also changes the exposure value by one f-stop, f11, f8, like that. So this is called as, this is important because this will help you to give a creative control over the camera by these changes are equivalent. It means that there are number of combinations that will give a correct exposure. As I said, the aperture, shutter speed, exposure. Okay, these are aperture, shutter speed, exposure are the interconnected. So 1 by 30 second at f11 is equal to 1 by 60 second at f8 is equal to 1 by 125 second at f5.6. So the f-stop and shutter speed reciprocity is as given. So we can try with the different combinations to give a correct exposure picture. So, okay, so this is important as it allows us to creative control over the camera by varying the aperture and shutter speed to get the both correct exposed and the creative effect we want in that image. Okay, so aperture, shutter speed or exposure plays a major role in the creating a picture in the professional or SLR cameras. Okay, so now we can test with some of the few images. So tell me, which is this picture is under exposure or over exposure? So the shutter speed is more. They have opened the shutter for more duration. So obviously the amount of light entered into the camera is more, and you got a overexposed picture, overexposed image. So which is the largest aperture in this picture? Okay, as like you see how the images have been taken. So the largest aperture in the third image. Okay, small or large aperture. This is an indoor. Okay, it has been taken in an indoor studio. Tell me, small or large aperture? Okay, so how these are all interconnected: aperture, shutter speed, and exposure, and which gives you the correctly exposed image. So that's it for today. Happy learning. Thank you.